My name is Andrew Osipov. I'm the Distinguished Engineer with Cisco Security Business Group. I'm very happy to be here. I serve in the role of CTO for the combined cloud and network security portfolio, so covering products like Umbrella, Secure Firewall, ASA, and FTD, Secure Workload, and everything that goes along with that particular portfolio. And so today I want to talk to you about Secure Firewall 3100. It's a mouthful, but what's behind the model name and the brand? There's some really cool innovation that I'm really proud of, something that Tom sort of alluded to, but let's get to first figure out, well, what's really are we doing? How does Secure Firewall fits into the bigger Cisco security story? And traditionally, firewalls and next generation firewalls for the last, 10, 15 years, they've been pretty much all about let's pick up every packet one by one, decrypt it, inspect it, bit for bit, move on to the next one. So not really much of cooperation beyond the deep packet inspection happening with firewalls in general. Two trends that I see my customers see are difficulty to insert network firewall into all kinds of environments, especially public cloud, private cloud, cloud native. And the second one is pervasive encryption of traffic. If everything's encrypted and not everybody decrypts everything for either performance or technical reasons, well, your firewalls, your IPS devices go blind. So if we keep doing what we've been doing for the last 15 years, we don't change, the firewalls are gonna go ahead and die. Really? No. So this is where Cisco is doing something to not let the firewall die, make sure firewalls, IPS devices are still relevant for our customers. There are two distinct use cases I see for traffic inspection, protection in general. One is I call it inbound. It's basically your users talking to your applications. You own the applications, so you are free to decrypt all that traffic. You could probably insert the firewall in between your outside users and your applications with relative ease. You can decrypt everything because you own the keys. Life is good. You can apply IPS, malware policies, WAF down the line, IPA gateway functions, whatever you want to attach to this packet inspection path. However, as you get more into outbound security, users going to outside applications, things get a little bit more difficult. Specifically, a lot of folks consume cloud-based productivity services, SaaS applications like Office, Google Workspaces. In many cases, there is no firewall or your controlled firewall in the path. So how do you ensure that whichever firewall that may handle some of those connections or may service those users has visibility into what is really going on in those cloud applications? This traffic is mostly undecryptable. Cloud services, cloud applications, actually every single, I call it thick app, something you have an actual app on your mobile device like a phone or a laptop, it tends to use bidirectional authentication with certificates. So you have the client verifying the server's identity as much as the server verifies the client's identity. You cannot decrypt those connections. You cannot cut in between because once you do that, either side is going to recognize it's not talking to the authentic client or the service, and decryption will fail. So one idea we actually deploy in Umbrella is to leverage a cloud access security broker solution, CloudLock, which hooks onto the backend API of those SaaS applications to extract the context around the session. Hey, is it Andrew going to Google Drive? Is it Andrew using Google Chat? Am I editing a document? So CASB can actually tell you that and link it back to the network level session. And then the job of the firewall, if it's cloud firewall, it's easy. Like, oh yeah, Andrew's in Google Chat. We didn't have to decrypt, didn't have to inspect. We learned that through the application directly. And that's the kind of information we want to bring into the privately owned. I don't like saying on premises because firewalls may be virtual and off premises, but a privately managed firewall. Then you go to secure endpoint. So secure clients, something that goes on the client endpoint, tons of data we can collect from there, process IDs, process hashes, user IDs, obviously, geolocation, FQDNs. For every connection that's opened from a secure client installed laptop, we actually collect about 30 plus parameters for every single connection, off and on VPN. And today it's all aggregated in a collector like Secure Network Analytics. Our plan is to integrate this information into firewall as well for more near real-time policy enforcement. So instead of the client just sending it to a collector for after-the-fact analysis, it can send it to the edge firewall. So the edge firewall can use those 30+ parameters in near real-time policy enforcement. And there is the machine learning inference. We can fingerprint connections. I'll talk about that a little bit later. We can actually determine what the application is or if the connection is malicious by studying just a few bits around the connection without doing full decryption. And that's the inference-based part of analysis. Then, of course, on the application side, we have tools like Secure Workload, which, just like we have tools attaching to the client, we have tools attaching to the application side and getting the attributes, getting process information, process trees, all that, feeding it back into the firewall. And again, augmenting the policy decisions, the overall context, doing things like virtual patching. It's a relatively, I mean, it's not a new concept, but it's something we are doing. It's pretty exciting for us. It's the ability to, instead of programming 10,000 IPS signatures on your firewall, because you don't know what applications, what specific versions you're running, program 5 signatures which are specific to this application running on this host, running this particular version. And that's the power of workload, something you never get out of the network-based inspection. So you can decrypt all day long on the firewall. You will never be able to find out with precision what software version this application is running, what vulnerabilities it has. Workload can tell us right away. We don't have to inspect anything and go deeper. So that's the overall strategy for our firewall. Hey, go from a lonely warrior doing deep packet inspection to still do deep packet inspection, but augment that with cooperation across the rest of the portfolio and inference-based analysis, machine learning and such. So now that we kind of got that framed up, let's talk about Secure Firewall 3100, which is obviously an important part of running secure firewall software, deploying that into customers' network. When you look at it, just an appliance, physical box, right? Hardware box. One rack unit, we purposely keep those small. We don't build refrigerator-sized boxes because we recognize that data center space is a premium. So the more we can pack in a smaller form factor, the better. It is either a next-generation firewall threat defense, or a classic ASA appliance. So you install the appropriate image, looks and feels like one appliance. It's got a lot of features coming in from our higher-end boxes. Clustering, multi-instance. We'll talk about some of those. Flow offloads, which is the way to accelerate certain trusted connections in the hardware. Of course, there are things like interfaces. That's all boring. You can install an external module with 40 gig interfaces. So again, it borrows a lot, even though it's a mid-range box we introduced to replace our 2100, the old appliances. It does pack a punch. It does bring a lot of features from higher-end appliances to, again, cater to those customers who want to have something more extensible. I always like to kind of look inside the box, see what's going on. I was in TAC many years ago, and when I was in TAC, I wanted to do a new Cisco Live session. I wanted to do a Cisco Live session which was specifically around the firewall architecture. I called it Maximizing Firewall Performance. And I spent countless hours sitting down with my engineering teams back then and learning everything I could about the inside firewall architecture. And so I built that presentation that not only explained to customers why things work the way they do and how the firewalls are built on the inside, but also kind of show diagrams like this. And funny enough, some of those elements, some of those design principles, they go all the way back to those days, like ASA 5585, long time ago, introduced the concept of this switch fabric inside. So like, why not go from the external interface straight to the CPU? Like, why build a switching fabric on the inside? Well, what we found out back then, a lot of vendors, and some vendors still do that, say, well, if you plug into this particular port on your firewall, you'll get great performance. Plug into this port, it'll be good, but it wouldn't be great. And don't plug into those ports, like those ports go last, because once you plug into them, they're way too far from the CPU, like things wouldn't go well. And that was a pain in the butt, right? Because like customers don't like to play this matrix of, well, which port do I plug into? So the switch fabric helps to normalize the effect of, yeah, this port is far versus this port is close. So all the ports we have on our appliances have equal access to the CPU, and so there is no like playing this whack-a-mole with your Ethernet interfaces or SFPs. Every port gets prime treatment in terms of the CPU bandwidth. But the second thing that is specific to the 3100, and that has to do with encryption. When we built this chassis, the specific goal was to build something that is optimized for encrypted traffic handling. That's what I went and asked engineering. I said, look, all the traffic is encrypted. Build me a box which is awesome with encrypted traffic handling, and everything else will follow. And so they did. And this bit in the middle, I call it the crypto offload engine, which is shown kind of here in the middle with this FPGA. That's what makes it different from everything else we've built, and frankly, most of the boxes other vendors are building. Traditionally, if you want to decrypt or encrypt the packets, you have the main CPU, you have this hardware crypto engine. When the main CPU needs to encrypt or decrypt anything, it sends the packet to the crypto engine. Crypto engine does its magic, sends it back. If you have to do double, like TLS decryption, you do this multiple times. Every time you do that, you cross the PCI Express bus, which is very, very slow in the sense of latency. So the CPU is fast, crypto engine's fast, PCI Express, it's not optimized for transactions per second. So that's why when you decrypt on modern firewalls, the performance goes down. So what we did in the 3100, we eliminated that back and forth between CPU and the crypto engine. We built this direct path between the FPGA in the middle and the crypto accelerator. So by the time packets get to the CPU, they are already decrypted. The CPU sends the clear text packets down. This FPGA talks directly to the crypto engine over a dedicated connection. It's not a PCI Express. It's called the interlink bus. And it's very fast, and so the packets get encrypted, and this is why you get this huge boost in performance numbers. I'm not really, I always say that I don't usually show datasheet numbers because, hey, anybody can go and look at those numbers, but those numbers are particularly impressive because they just show how much this architecture does with encrypted traffic. Like even the top end number, like application ID plus IPS, those are huge, right? You go from 17 to 45 gig on those numbers, which for the mid-range box, that's pretty impressive. But as you dig into the IPsec numbers, you can do something like 31 gigabit per second on a single tunnel, which is really carrier-grade performance. Like there's few boxes out there, purpose-built carrier-grade SP purpose-built boxes that can do that kind of throughput on a single tunnel with IPsec. We can do that because of that inline crypto engine. That's really the innovation behind this performance boost. So the hardware, obviously there. So what else do we do around the hardware? So I mentioned a few features that we borrowed from the higher end appliances. Clustering is one of them. Clustering is one of the technologies I've worked on for the last 10 plus years. Again, tons of innovation around that. Clustering is a way to build a bigger logical firewall out of smaller physical boxes. And that's why we keep building 1 RU boxes. So instead of giving you an 18 or 38 RU single stack, you can buy 8 3100 appliances and group them into a cluster that will look and feel like a single logical firewall, but it's fully distributed. So if one fails, no big deal. You can add and remove them without affecting traffic. So that's a big benefit of clustering. One other benefit is in the ability to pin every single packet for a flow to a single cluster member. It works for HA, active standby, right? We do that because, well, if you active standby, only the active unit will always get those packets, so no harm done. For clustering, or what the industry calls clustering, the approaches differ. Some just fan packets across, and if the forward leg and the reverse leg of the connection land on different cluster members, too bad. You just missed a bunch of security context, but you processed the connection.
So Andrew, I got a question. Is the logic behind that the same as it was for the ASA firewall clustering?
It is. It is similar to ASA. The consistent hash behind it, sort of like a RAID 5 way of backing up just enough of the connection information somewhere else. But there's also a lot of the next generation firewall magic thrown in because you have IPS states, you have some of the other complexities for like TLS, for instance, decryption. So yeah, baseline, it's still similar to ASA clustering, but a lot more magic thrown in specifically for the next generation firewall. But yes, essentially that's really the approach, right? Instead of having 2 units try to process the same connection in parallel and miss half the context, we normalize it down to, hey, all packets will always come to the same unit, call it the owner, and it will process the connection from the beginning to the end until it fails or unless it fails. And this is really the, again, the innovation from the higher end appliances going into the mid-range to give you that scale as you grow, pay as you grow, different ways to call it, capability on the 3100s. Then there is multi-instance. That's also something that solves a problem I've encountered many times. I used to work in tax, so I'd see a situation where a customer creates multiple virtual firewalls instead of physical appliance, and they assume there is separation. Well, there is some separation, but it's all running on shared hardware resources, so it's not uncommon for one tenant to spill over and affect some other tenant, and sometimes you see a lab environment spilled over and took down production. So when we kind of looked at the multi-tenancy on the firepower back then appliances, Secure Firewall now, I said, look, why don't we design this with full physical resource separation in mind? So you don't have to have the situation where one tenant spills and affects something else. So multi-instance is actually a bunch of Docker containers running on a single physical platform. They are completely walled off into their own CPU, memory, disk constraints. Crypto accelerator cores are divided appropriately and proportionally as well. And so you can create differently sized tenants, big, small, assign them interfaces, and then you have the assurance that if one spikes, it would not spill over and affect traffic through any other tenant. Again, something that's extended now to the Secure Firewall 3100 from the higher-end appliance family.
So again, how does that work with the clustering functionality? Do you have clustering and then you build the tenants on top of it so it splits it out?
So you can have clusters of instances. So you can cluster multiple instances, and you can have multiple clusters, and then you can have, it actually becomes really cool because it abstracts the hardware from the logical firewalls. You can build multiple clusters, multiple HA pairs, and multiple standalone firewalls on a single pool of appliances. And one really cool thing, in normal clustering, single instance, you cannot mix different appliances. With multi-instance, you can mix different appliance models.
Because you have the abstraction layer.
Because you size the instances based on CPU, and CPU cores are approximately same across multiple different, it's not quite same, but approximately same. So you can have like a 4110 in a cluster with a 4145 as long as the instances are sized the same. So that's a big benefit of clustering in multi-instance specifically that comes forward. Talked about TLS. Again, the platform is built for crypto traffic. Do you have to always decrypt everything to get visibility? No. We build tools for URL filtering and application ID that do not require decryption to identify those. Some work based on outer headers, some work based on fingerprinting and machine learning technology behind it. But if you want to do IPS file policy, something in depth, obviously you have to decrypt. And that's why we keep building those boxes, which are very, very fast at decryption, decrypting TLS 1.2 or 1.3. There is actually very little difference in horsepower required between 1.2 and 1.3. I participate in TLS working group at IETF. There's always myths about 1.3 is not decryptable. Very much decryptable. There's three main differences, I should say, being purist. 1.3 makes certain cipher suites mandatory, which 1.2 didn't, but in real life, most, if not all, 1.2 connections still use a strong cipher suites. 2, 1.3 enforces perfect forward secrecy per session keys, Diffie-Hellman. Again, every single 1.2 connection out there, as long as the application is secure, will use Diffie-Hellman as well. Third one is different, not tremendously different, but different. TLS 1.3 encrypts every single handshake message except for the first one, client hello, which is what makes the visibility into 1.3 challenging for like web proxies, URL filtering devices, which actually rely on the TLS handshake to extract certain fields in clear text. And we have some techniques ourselves to kind of bring 1.3 visibility back down to 1.2 level without compromising the session privacy. But again, 1.3 is just as decryptable if you want to decrypt as 1.2. As a corollary, is just as undecryptable if the application really doesn't want you to decrypt. So there are totally ways to prevent decryption by, again, simply exchanging the keys between the client and the server out of band, or the server provisioning a client certificate directly, and then you cannot cut in. And this is why you need other ways of detecting threats, detecting applications without decryption. And so one way is something we call the encrypted visibility engine. And that's a machine learning driven capability to fingerprint connections based on the outer headers and only program those fingerprints into the firewall to match connections to known applications. A classic example is, say you have a Firefox browser. Not a lot of people do, but there's still some. On your laptop, right, you have Tor, the onion router. It's one of those anonymizing software tools which plumbs the tunnel through your edge firewall to hide what you're doing. Normally, firewall can't tell the difference unless you actually decrypt, because HTTPS over TLS, well, who knows what's inside. So we developed this solution. This is all Cisco engineers developed. We actually put it out as an open source project because hey, we want to contribute to the goodness, to the security of the open world. It's called Project Mercury. There's a link. If you want to follow the link, you can download the code, play with it. What it does, it actually fingerprints. It looks at just a few fields on the TLS handshake, and it's able to classify connection as Firefox or Tor with very high confidence just based on those few fields. And it's actually incredibly accurate. It's accurate to the point where we did some testing. It also does now malware detection, so it can look at certain patterns and fingerprint malware connections. Actually, so effective, it's in many cases more accurate than when you start doing proper deep packet inspection and pattern matching, especially with evasive applications, because it's very easy for the evasive application to change a few things in the kind of the pattern of behavior to evade the application ID signature based on a template. But it can't really change its behavior at the connection level. So this is why encrypted visibility engines, actually, we're finding it a more effective tool to identify certain apps and detect malware without having to continuously redo those template-based detectors. The way it's exposed to customers, if you look at the events on Firewall Threat Defense and Firewall Management Center, you see those new fields which talk about the process name and the confidence level. So for instance, in this example, EVE is 100% confident this connection was opened by wget. And we also have malware scoring. So we're 50-some% confident this connection was malicious. This malicious scoring capability is not used for active enforcement yet in next release, and I'm kind of getting into the roadmap, but hey, I'm excited enough to share that with you. In next release, the customer can block connections based on confidence and say if it's 90% malware confidence, block it. And in the future, we'll also do selective decryption based on that confidence. If it's a trusted application and the malware confidence is low, do not decrypt it. Right? So this way, you can direct your resources into connections which are potentially malicious versus spread it across, peanut butter it across the entire set and lose out on potentially, risky malicious connections that slip through the cracks. So that's really all I had to share in connection to the 3100 and the associated secure firewall features.
I've got a quick question. Do you see any performance hit from the newer cryptographic protocols like Suite B or anything like that? Is that something that impacts the performance of the box?
So it does in cases where there is a cipher suite which isn't natively supported in the hardware, but there are very few in the common ones, like for instance Cha-Cha, that's something we support. But yeah, you get into Suite B, and again, there are some that aren't hardware accelerated. And then you would, but normally, like in the most commonly used ones we see, we don't see any additional. There's definitely a penalty from decryption in general, but not specifically, not as much extra for Suite B.
I have a question regarding 3100. Do you have kind of lessons learned from that? So you replace a 2K line, now the stats are much better than expected, so it's kind of not a small performance, but it's a big one for the next generation. I see that also the data center line will maybe renewed. Do you have any kind of, let's say, lessons learned from that experience that you will implement in future stuff that you will maybe have?
Yeah, definitely. And like you alluded to, right, 31, obviously the first refresh will be more. And as we deliberately started on the mid-range because it can be extended down to the low end, can be extended down to the high end. So one lesson is we need to have a bigger link between the switch fabric and the CPU because of the flow capability. I just met with a customer and I said, look, 3100 has a 50 gigabit link between the switch fabric and a CPU, which limits the flow offload capacity as well. But we know it's a 45 gig box, but what if we want to offload 100 gig of traffic in that FPGA? So one takeaway for me is, well, we got to beef up that link so we don't have to always go to the CPU. We can actually offload it like 200 gig a second rate without even impacting the CPU. That's one. The second one is, yeah, do more inline crypto acceleration for TLS. That's definitely the direction that customers are going.
And the crypto chip and the acceleration engine, that is completely Cisco ASIC?
So it's a combination of Cisco and third-party components. We always work, even if we use a third-party component, we also work with that particular vendor on custom firmware. So it's not 100% Cisco hardware, but it's a programmable chip that is using Cisco designed firmware.
As I understand it, the 3100's got some like IWAN capabilities, sort of almost SD-WAN type. Do you know if that's going to filter down to some of the lower end products? Because kind of it looks like it would sit quite nicely in a branch, but with that much performance, it's kind of over-spec'd. So just wondered if that's also going to filter down.
So all the WAN capabilities are software specific. So you have policy-based, application-based PBR, you have multi-link load balancing, you have path monitoring. All those capabilities are software specific. So every single firewall we build gets the same capabilities with the upgrade. It's not just limited to the 3100. So from 1100 all the way down to some of the end of X platforms that can run the software will have this capability today. So again, we always separate the software from hardware. Hardware is to support the software, but we recognize that customers don't always run our hardware. There is virtual, there is embedded, like work we're doing with the Catalyst team. So yeah, the WAN capabilities, they extend across.
Could you explain a little bit more how you do the decryption? I mean, you need to get some secrets from somewhere, right?
So decryption is done for outbound. Essentially, you have to provision the firewall's own certificate into the trust store of the endpoint, which is why I don't like outbound decryption, because that's a challenge, one, because you have to have managed endpoints with the certificate pushed down into the trust store, and then the application might break it. For inbound, all you need is the server's certificates, server's private keys, and then you're good to go. No worries.
Do you share some of the intelligence from Talos with the fingerprinting, or is it just on box itself?
No, so the fingerprinting is actually done off box. We analyze all of the Cisco traffic, Cisco application traffic to build those fingerprints. So that's the beauty of this solution, right? The at scale machine learning capability is running in our data centers. All the firewall gets is a small fingerprint that it matches to certain things in the connection. It doesn't have to understand why those fields match. All it has to do is to say, okay, this matches to this, hence it is this process or this particular malicious software. So the nice thing about Encrypted Visibility Engine, it's zero performance impact. We could not find any performance impact in our lab testing beyond normal deviation.
One follow-up question on the Encrypted Visibility Engine. I saw really strong in the Cisco world, kind of you try to integrate with the other Cisco security products. Mm-hmm. Are there any kind of, will this come maybe to Umbrella or other Cisco security products?
That's a bigger conversation. I think definitely between Umbrella and Secure Firewall being two parts of my portfolio, we're looking to normalize the firewall engine between the two. But again, that's a different chat for a different day.
Can you also, if you're doing something like this, to detect, you're detecting which application has initiated which kind of traffic, mm-hmm. Can you also determine between what kind of activity a user is doing? For example, if you're going to Twitter or something, it's one thing to read Twitter, but it's another to post something. Would it be possible to determine what is going on?
So not in today's capabilities, but definitely the technology itself allows that. So we will continue investing into it, and hopefully one day it will let us do just that.